The last new concept for grade 11 is graphing a reciprocal function. So what is a reciprocal function? All of these are examples of reciprocal functions. They are, if you think of the function as being f of x, if f of x is 2x, the reciprocal of that is to go 1 over f of x, which would be 1 over 2x. Okay, so all of these are taking a function and taking the reciprocal of them. So that's what we're going to learn how to do, to graph those. Couple of things, a review. Where is each of these rational expressions undefined? Here x can't be 0. Here x can't be -4. Here x can't be plus or minus 3, right, if you factored that. And here x can't be 1 or -3. Okay, we learned that in Unit 7. So let's take a quick look at the original y equals 1x. This is a basic reciprocal graph. To do that, I want you to first of all think about this graph. I want you to think about the graph y equals x. Okay, the graph y equals x, you already know. It's a straight line. Okay, so whenever you do one of these graphs, I'm going to get you to draw whatever's down here, the original graph. Okay, now look what happens when you take the reciprocal. The reciprocal means to go 1 divided by whatever that value is. When we had x is -5, y was -5. But now when I take the reciprocal, I'm going to get -1 over 5. I'm going to get -1 over 2, and 1 divided by -1 is -1. 1 divided by a half is -2. And this is, now what happens when you go 1 divided by 0? You can't divide by 0. Okay, and now the positive values are going to give you the same as we just had. Okay, so let's take a look at what that looks like on the graph. So let's start here, for example, the very bottom of the table there. When you had when you had the graph y equals x, and if x is 5, y is 5. That's what this point is right there. But what does it look like when you take the reciprocal of 5? You end up with 1/5. The reciprocal of 2 was 1/2. The reciprocal of 1 was still 1. Okay, and then let's look at this when x was 1/2. If x is 1/2, the reciprocal is 2. When x was 1/5, we got 5, and so on. Let's do the same thing with the negatives. Okay, you're going to get 1/5, 1/2, 1. So something like this. And then you have this weird one here. What happens at x is 0? You have what is called undefined. And undefined gives you an asymptote. This is the asymptote, x equals 0. Okay, what is an asymptote? An asymptote is a value that x is not defined at. Okay, that's part of it, but it also will help you with what we call behavior. Okay, so let me just write some of this. We have an asymptote at x equals 0. Why is that? Okay, because x cannot be 0. That's the first reason. And this also tells me what happens as x approaches 0. Okay, as it gets closer to 0, what happens? Well, let's take a look at the graph. So, if you look at what's going on right here, when x was 1/2, we ended up with the reciprocal being 2. The reciprocal of 1/5 was 5. The reciprocal of 1/10 was 10. The smaller x is, the bigger the reciprocal is. And so what you have here is values getting bigger and bigger as they approach the asymptote, never crossing the asymptote. Down here, the bigger x's, you think of x being 100, well then you have 1 over 100. Think of x being 1,000, then you have 1 over 1,000. The bigger x gets, the smaller this graph gets. In fact, it gets smaller and smaller, but never gets to 0. Here there is another asymptote. And by the way, for grade 11, there will always be a horizontal asymptote at y equals 0. Next year, you'll get something different than y is equal to 0, but for grade 11, there will always be this asymptote. Okay, what happens on the other side? Well, again, as x gets smaller, the reciprocal gets bigger. As x gets bigger, the reciprocal gets smaller. Okay, so those are kind of the steps to graphing a reciprocal function. Okay, let's take a look at some of the key points there. Okay, so recall that the reciprocal of a number x, where x can't be 0, is just 1 over x. So that's what we're doing. We're going to take some graph and going 1 divided by that graph. Okay, similarly, if you have a f of x, 1 over f of x is the reciprocal of that graph. Okay, let's look at an example. Here you have y equals x minus 1. If I take the reciprocal, it's going to be 1 over x minus 1. A couple of key points. Okay, the graph of y equals 1 over x minus 1 has no x-intercept because 1 over x minus 1 is never 0. So there is a horizontal asymptote. This is what I told you in grade 11. It will always be like this. If you have 1 over something, no matter what that f of x is here, you will never have a value of 0. That's why we have a vertical asymptote. Sorry, a horizontal asymptote there. Okay? So that's the sort of the first thing. You're always going to have an asymptote at y equals 0 for grade 11. The other thing to look at is your non-permissible value. Wherever there is a non-permissible value, there will be a vertical asymptote. In this case, if you put a 1 there, you would get 0 in the denominator. So that tells me that there is a vertical asymptote at x equals 1. Okay, asymptotes are lines that the graph approaches but never touches. By the way, on Desmos, you can't see them. They don't put asymptotes in. They're not part of the graph. We put them on the graph just so you can see what's going on, but they are not really part of the graph. Okay, that's why we use dashed lines. Reciprocal functions are discontinuous. In other words, there will be a break in the graph. For example, y equals x is continuous. A parabola is continuous. Okay, but anytime there is an asymptote, it's discontinuous. All right, so let's try another one. Sketch the graph of y equals 1 over negative 4x plus 3. Okay, first of all, graph this. This is what we're taking the reciprocal of. So we'll have an x-intercept at negative 3/4. We'll have a y-intercept at 3. So I'm going to put that there, and I'll put this here. Okay, so that's the line y equals negative 4x plus 3. Okay, so we're going to start to do that. That's sketch the basic graph. Now we're going to do the reciprocal. All right, we don't need a table of values. Okay, how are we going to draw the reciprocal? Well, first of all, you should consider what can x naught be? What are the non-permissible values? Okay, well, if you're looking at 1 over 4, negative 4x plus 3, it will be the value that makes this equal to 0. Okay? So where is negative 4x plus 3 equal to 0? Well, this is going to be your... Oh, did I make a mistake? Let's back up a little bit there. The x-intercept is positive 3/4. My mistake. Okay, so now let's back up here. So the x-intercept is actually the value that cannot happen for the reciprocal. Because if you put 3/4 in there, you're going to get 1 divided by 0. So wherever the x-intercept is, the reciprocal graph is going to have an asymptote. Okay, so let's make that note. Where f of x equals 0, 1 over f of x will have a vertical asymptote. Okay, this is one of the reasons we draw the original graph, so I can see where the x-intercept is. That will have the asymptote. Okay, now the second one, you know that there will be a horizontal asymptote here. Okay, now I told you that's going to happen every time. But why? Well, if you think about this graph, is there a value you can put in here so that this will equal 0? There's nothing you can do. No matter what you put into x, you're going to get some number here, and it'll be 1 divided by that some number. You're never going to be able to get 0. Okay? In fact, why don't you try that? Why don't you try and make it equal to 0? If we make it equal to 0, let's cross multiply. 1 equals 0. Does 1 equal 0? When does 1 equal 0? This never happens. Okay, it cannot happen. 1 cannot be 0, so you were never going to get a value of x to give you y is equal to 0. That's why there is a horizontal asymptote there. Okay, so that's your start of the graph. Now look back here. What did we also notice? Did you notice that where x was 1 or negative 1, the reciprocal is still 1 and negative 1? Okay, so what we're going to do here is find the value of 1 and find the value of negative 1. Those values will still be the same. And now let's take a look at the original graph. What's happening with this line going down here? The values of x are getting bigger, negative. Okay, now if you take, so what I'm saying is f of x is getting bigger. So I'm going to use an arrow like this, so it says getting bigger. Let's say getting big as infinity. Then what's going to happen to 1 over f of x? If f of x is getting really big, say like 1 million, what would 1 over 1 million look like? It would be really small number. Almost 0. So what this statement says is as f of x approaches infinity, so as f of x gets really big, the reciprocal approaches 0. In other words, gets really small. Okay, so as f of x is getting big, 1 over f of x is getting small. So going back here, what's happening with this graph? It's getting really big negative. So let's get really small negative for the reciprocal. Okay, so just as an example, if you said x is 100, and you put that over here, this is going to be a really big number, but when you take the reciprocal, it's going to be a really small number. Okay, now look what's going on right here. This means that the y value, the f of x values are getting smaller and smaller. They're getting closer to 0. The reciprocal of that is to get really big. Okay, so let's write that as f of x, as the original line, that red line we have there, as it approaches 0, then 1 over f of x will approach really big numbers, infinity. Okay, so let's look at this a little bit closer here. What's happening with this line right here? The values are getting bigger and bigger. The original graph, f of x, the lines are getting bigger and bigger. Okay, it's approaching infinity here. What's going to happen when I take the reciprocal? Well, from the value of 1, if the values were getting bigger for f of x, for 1 over f of x, they're going to get smaller. And here, they're getting smaller. Whoops. Then the reciprocal would be getting bigger. Okay. And one other point. How do I get this? Well, this is your basic, what you're doing with reciprocal. The original f of x was 3, so then 1 over f of x would be 1 over 3. So this point right here is 1/3. Alright, there's your first look at drawing a reciprocal graph. Now don't forget, the red graph is not part of the graph. The reciprocal is just what you see for the green there. Okay, we'll try another one. Sketch the graph of y equals 1 over x minus 3. Label all intercepts and asymptotes. Okay, now what I've got here is kind of the how-to, this box right here. Alright, so we're going to do that again. Let's start by graphing y equals x minus 3. The x-intercept is 3. The y-intercept is negative 3. Negative 3, positive 3. That's f of x. We now want to do 1 over x minus 3. Okay, we want to do 1 over f of x. Okay, step 1. What's step 1? Well, where is the non-permissible value? What is the non-permissible value here? It happens to be the x-intercept, 3. So there will be a vertical asymptote there. Okay, whatever the non-permissible value is, x cannot be 3, so we'll draw a vertical asymptote at x equals 3. That's step 1. Step 2 is there is a horizontal asymptote at y equals 0. Again, if you don't believe me, let's see if we can have y equals 0. Well, if you cross multiply, again, you get 1 equals 0. This is not possible. So there is a horizontal asymptote at y equals 0. Okay, next step. Where is the red graph? Where is f of x equal to plus or minus 1? Well, negative 1 is about here. Positive 1 is about there. Those are what we call invariant points. Because if you go 1 over 1, it's still 1. If you go 1 over negative 1, it's still negative 1. Okay, so those are invariant points. And now we just have to draw our curves. Alright, remember where f of x gets bigger, 1 over f of x gets smaller. So where is this graph getting bigger? Here and here. Okay, so let's put this line here because the original was getting bigger, so we're getting smaller. And here we're getting smaller. Where is this graph getting smaller? The original f of x, it's getting smaller right here and here, right? It's getting closer and closer to 0. So the reciprocal should get bigger and bigger. Okay? Now you're kind of maybe looking at that and going, I still don't really understand what's happening. Well, let's pick some values here on this graph to show you what happened. Okay, let's say this value on the y is half. What's the reciprocal of a half? 2. So it would end up going up here, where 2 is. Okay, let's pick this value. Let's say this is 2. What would happen to 2? If you take the reciprocal of 2, you would get 1/2. Let's say this value is 10. What's the reciprocal of 10? 1/10. Let's say this one was 1,000,000. What's the reciprocal of 1,000,000? Well, like decimal 0.0000001. It's a very small number. Okay, so that's kind of what we're doing. We're taking the values of f of x and taking the reciprocal of them to make them look like the graph we've got there. Okay? Now this is saying basically to do the exact opposite of what we were just talking about. It says use this graph. So this graph, you can see here is this reciprocal graph. It's saying, well, what is the original graph then? So it's like working backwards. Okay, well, what does this vertical asymptote tell me? That tells me that if x cannot be negative 0.5, that tells me that the original linear function had an x-intercept at x equals -1/2. Okay, what else does it tell us here? Is there anything else we can see? Well, we can see that the original graph had a y value of 1 right here and -1 right here. Okay, and it had an x-intercept at -1/2, and those 3 lines should be enough to draw the original linear function. Okay, so that's all you had to do for that one. Alright, I'm going to give you some questions. I think you can give those a try, see if it makes sense. Make sure you ask if you have things that are not going well. For today, if you're going to try those questions, you can use Desmos because you may be still stuck on some of them. I would say all of these, if you're stuck, you can use Desmos. Just remember that the asymptotes aren't shown with dotted lines or shaded lines. Okay?